Hello everyone. This video is a presentation on visualizing AWS Cloudtrail data using Solr and Banana. This presentation gives an introduction to the Cloudtrail data, its attributes, and the set of tools required to analyze and visualize the data. AWS Cloudtrail is a part of Amazon Web Service platform, which offers various services in your AWS account. Monitoring your activities, keeping a log of it, etc. can be done with the help of Cloudtrail. It helps to simplify the security analysis and other troubleshooting issues. These data can be downloaded by the account holder and use it for his analysis. The above mentioned data can be downloaded in multiple formats such as CSV, JSON, XML, etc. But for this project, we have made use of JSON format. This is the snip of the data extracted for our project. The complete dataset contains 35,000 JSON files and consisting of 20 attributes. Further explanation regarding this data would be discussed later. Now, let us look through the tools required for the visualization and how to load the data into it. GitHub is an online Git version control repository hosting service. Git is a version control system for tracking changes in computer file systems across multiple users. We used GitHub as a platform to share and update our reports, codes, presentations, etc. We made a repository in GitHub and named it as Cloudtrail. You can see the snippet here which shows that we have made a repository named as Cloudtrail. GitHub is also useful to download the necessary tools required for the Cloudtrail visualization such as Solr, Banana, etc. GitHub Desktop is a desktop downloadable application of GitHub. This eased our efforts of integration as multiple users had access to update our work, due to which all the teammates in our project were able to update in a single platform. Just pushing the file and committing it gets the file directly into the repository.
So we are using Apache Solr for indexing and searching the JSON files that were provided from the AWS Cloudtrail. So Apache Solr is an open source search platform which will be written in Java under the Apache Lucene platform. So here mainly we will be using Solr for loading the data from the JSON files provided. So the prerequisites for running all the setup that we require is a Java runtime environment, which is 1.8 or higher, and we need to add the environment variables in Windows and then edit that to Java home, and we can install Solr from the link that was provided here. So the link opens an Apache Solr page where we can download the Solr files. So this is pausing for 3 seconds to redirect to the file that we are required. So we can download the 7.1.0.zip and save it to a local file. So in order to run the Solr instance, we will use the command prompt, and we need to change the directory to the folder where we have stored the Solr. So the same directory should be used in the command prompt, and Solr start command is used to run the statement, and the Solr will be starting on the port number 8983, which will be served on the local host. So once we go into the web browser and localhost Solr, we'll get a Solr instance that will be reflected over here. In order to load the data, we need to have some codes where we will be having all the data that will be loaded from the JSON files that are provided to us. So in order to create these codes, we can directly create in the Solr instance itself, or from the command prompt we have to create a core and give a core name to that. So here the main core name that we are giving is Cloud Test. Once we enter, it will create a core name and we will be seeing a Cloud Test core over here. So in order to load the data into the Solr instance, we have used a Python as base, and we have written some code in PySolr. So here we have set the path of the data set in the path variable, and we have imported some files into the command prompt so that the PySolr works smoothly. So and we have imported the JSON file because we have all the data in JSON. So later we have used os.list directory in order to list out all the files that we have. So once we see into the data, we have a year, and in that we have all the months where the events are recorded, and in each month we have all the days where the events are recorded, and in a particular day each instance is recorded. Here we have used all the for and if loops to go into each folder in the Cloudtrail dataset. So once we go into months and days folder, so we get all the list of files in the directory, and we can save these files into the files variable. Once we load all the files in the files variable, we are printing each and every file in order to see whether we are getting the required output or not. So once we get the required output, we will be opening each file from the complete file name variable and loading this data into the JSON format into the data variable. So for adding the Solr for adding the data into the Solr instance, we'll be adding a command solr.add of all records to get the data into the Solr instance. So once we run this code, I will be having the Solr with the fully loaded data. So once we look into the cloud test, we have a set of records we have run from the code that we have written. So once we go into the query option and execute query, we will get all the data in as required file JSON format. So once we load the data into Solr, we have to visualize the data using Banana. So Banana is a data visualization tool that uses Solr for data analysis and display. So in order to integrate the Solr with Banana, first we need to download Banana from the link that is provided in the GitHub, and we need to add the Banana folder into Solr 7.0.0 server, where we have a Solr web app, and in that you should go to the web app directory and copy the Banana folder in here. So once we copy the folder, we should go to the localhost 8983 Solr Banana .index.html. So we will load the Banana dashboard like this. So after creating a dashboard, we can create a new time series dashboard or a non-time series dashboard as per the requirement. So here we have created a time series dashboard, and once we have created the core that should be given in the collection name, so we have to give the cloud test in the collection name, which is the core, so that we will load the data from Solr to Banana. So once we create, actually we should click on create, and we will get the number of total hits as the number of records that will be loaded into the Solr. So this will be each record that will be loaded into the Solr, and here we have all the attributes those are loaded into the Solr.
After listening to the Banana dashboard, we'll be looking into the visualization part of Banana, where the data residing on the Solr is being visualized. What do we mean by visualization? Visualization means filtering out the data to focus on relevant items, whatever we feel important to be analyzed from our dataset. We have chosen D3 for this visualization in our project because Banana uses D3 library internally. That's the reason why we have chosen D3. D3 is a JavaScript library for manipulating documents based on the data. D3 helps to bring the data to life using HTML, SVG, and CSS elements. What do we mean by SVG? It's a scalable vector graphics. It's an XML markup language for describing two-dimensional vector graphics. In D3 JavaScript library, it loads a given dataset, then for each of its element creates an SVG object with associated properties and the behavior of that element. This is how basically the visualization is done in D3. and the data binding. And the data in D3 visualization is always a form of array, so we have chosen JSON file format for the visualization. D3 API contains several hundred functions and they are grouped into a logical units in the following format. Like selections, we have colors, scales, SVG, layouts, and behaviors. Variety of data transformations. Among all these, we have chosen line for our POC in the project. And this is the basic folder structure if we see here. We need a data file which is in the array format as I mentioned you before. The right side in this is a typical JSON format data which we will be visualizing using a line chart. We have configurable functions in D3. That's why we have chosen D3.line to be our function for our exploration of D3. This is a simple code snippet for loading JSON data using the D3 visualizations on Banana. So left side is a typical HTML format, and towards the right we have a JSON file which is being loaded, and the data binding is happening using the d3.json. And the canvas.append is we are appending the SVG elements to it, and we are going to read through the function format of the student details as we are exploring the student details of which have three properties like ID, name, and age. We'll be plotting the name on the x-axis and their respective age on the y-axis. Now this is a line chart output which we visualized using the D3 library. And the integration as a Banana custom panel on the files which we have explored, and the folder structure in Banana will be explained by my teammate Bharat.
So far, we have seen the functionalities of D3 and its usage in Banana. Now, let us look through how to create a custom panel in Banana. For this project, we have attempted to add a custom panel of pie chart and line chart visualizations in Banana. Any custom panel needs to contain three sets of files, that is, editor.html, module.html, and module.js. So, we can see the path provided here. So here we can create a folder and name it in the visualization which we are planning to do. As in our case, we are planning to create a pie chart. We have created a folder in the path, and if you go inside the folder, you can see a three set of files. That is, as I've discussed, the editor.html, module.html, and module.js. So to give a brief functionality of each of these files, editor.html connects the user interface of the panel, and the module.html and module.js uses the AngularJS derivatives to connect the functionality of module.js to the user. Module.js contains the D3 scripts essential for the visualization. After creating these files, they need to be in a folder under the given path. After placing the file in the right path, the panel name needs to be added in the config.js file present. The config.js file can be found in the source path here. So here we can see that once we open the file, we can see a small snippet which contains an array named as panel names. So once the process is complete, we need to add these two names, that is the line chart and the pie chart, inside the panel name array. Once this is done, we need to refresh the cache in the web browser. This is used to show the contents changed in the code that can be again viewed in the UI. So once this is done, we can start the Solr instance and refresh the Banana dashboard. Once we lead to the core and try to add the panel, we can see the add panel interface would be consisting of the two new panels which we have created, that is the line chart and the pie chart. So this is the sample output of the pie chart we have created. Here you can see, including the pie chart, we have a set of additional parameters such as the donut chart and the tilt chart. In the pie chart, we can see the sort by function can be functioned with help of index as well as the count.
Here we're going to see through the different fields that present in the AWS Cloudtrail data. These fields are about the user identity element in the Cloudtrail. User identity element contains the details about the type of IAM, identity, and access management identity that made the request and which credentials were used. So these following fields are the user identity elements. So let's go to the type. The type is like the type of the identity. We have different types like root, IAM user, assumed role, AWS account, and AWS service. Coming to the next type of fields. So these fields are Cloudtrail record contents. So the body of the record contains fields that help you to determine the request action as well as when and where the request was made. So when we see the event time, the date and time the request was made, it is coordinated in the UTC time format. Coming to the event name, the request action, which one of the actions in the application interface for that service. So, for example, service logging or event logging, like that. Coming to the AWS regions, this is a different type of regions that are present in the world. There are about 14 regions that are for the Amazon Web Services. And going through this, here we have different type of fields like request ID, so the value that identifies a request, and the event ID, which is unique identity generated for each event. And there are so many event types, and there's recipient account ID, and there are. So as we discussed about different type of fields, let's go through the visualization part. So we're going to start the visualization part with the event name. As we discussed, event names for the event that occurred. They are like which describes the volumes, create, snapshot, delete snapshot. There are some types of event names we observe in the data. So here I used a pie chart, which is the customized panel we created for this project, and you can see the distribution of the event name across these pie chart. As we can see, this describe scaling activities. This is the most event name that occurred in the data we have, which is 47%, and they describe auto scaling groups, which is 26%. So describe instance health, this is 24%. So remaining contribute the remaining percentage that we have that count to 100%. And let's go into other visualization. This is AWS region. So as I mentioned earlier, there are 14 AWS regions in the world. So for this data, there is only one AWS region, that is US East one. So the US East one is the North Virginia, and we have some more like US East 2, which is Ohio, and there are other AWS regions. So this is a pie chart which is of a donut type. So that's why you see a hole in the middle, and it shows that there is only one region present for this data. Going to the other visualization, this is a table. It's a table of contents. Like you can display the required fields that you want me to display on the table. So here I show you the event name, event source, and the event time. So this is the panel where you add the different fields that you want to describe in the table. Let's go to the other visualization, which is the bar chart. This is a very important one for this data. So here I have created the bar chart for the event source. So we have different type of sources where you get the events. So we want to use the auto scaling .amazon.aws.com, which is a high frequency. So this is the mode where you get the request from. And let's walk through the Amazon EC2 instance. So what is Amazon EC2 instance? EC2 instance, Elastic Cloud Compute. It's a virtual computer running Windows on which we install and run the applications. So for this instance, we need to create a key value pair first, and we want to choose the type of instance we want and the configuration settings, and we're gonna add the storage and everything on to make a instance, and we lost the instance. So we created an EC2 instance, but unfortunately we experienced some issue when loading the data, like we unable to process the data at a standard rate. Like there is processing rate is very slow. So for the above reason, so we did the entire project on a local system. So this is the EC2 instance, which looks like you can see the IP address and memory and everything on the display. Now you are seeing the demo of that Banana dashboard that we discussed earlier in the slides. Here there are some other panels I created for the other entities in the data. So here I want to show some feature where when you select one of the attribute in the panel, you're going to see changing the entire Banana dashboard. Third, you can see in the filter here where the field is event name and the value is describe instance health.
Through this project, we have explored Cloudtrail data, and its attributes are explained. We have played with the installation of Solr and Banana and D3 visualization in Banana. We also added a custom panel in Banana, and analytics are being performed on the Cloudtrail data through the custom panel which we have added. Thank you for giving this opportunity. Thank you.